Okay, let's dive right in. Picture this. You've just built a slick, brand new AI feature. You open up your browser, fire off a prompt, and boom, it works perfectly. The demo looks like absolute magic, your whole team is cheering, and honestly, your first instinct is to push that code straight to production. But hold on a second. What actual evidence should exist before an AI feature, one that can affect real money, alter official records, or totally tank customer trust, is allowed out into the wild? Well, welcome to The Explainer, where we are going to break down the exact, absolutely no-nonsense production readiness checklist you need before you ship.
You know, for years, the software industry got incredibly comfortable with a frankly dangerous workflow. Demo, looks good, ship. But when we're dealing with non-deterministic AI models, that old way is literally a fast track to disaster. We have to completely replace it with a rigorous gate. It should be release candidate, followed by hard evidence, resulting in a strict ship or hold verdict. We aren't just building fun little toys here, we're building systems that act on behalf of your entire business. So here's our roadmap for this explainer. We'll start with the demo delusion, move into the release gate architecture, and then stress test a realistic refund agent. After that, we'll hit planning for AI failure, observability and system limits, and finally, the final release verdict. Let's get to it.
Part 1. The demo delusion. Why plausible but wrong is the real risk.
Here's the scary truth. AI models are dangerously good at sounding super confident while failing completely silently. When an AI tool misunderstands your system's intent, the output often still appears perfectly correct to the human eye. It's plausible, but wrong. So, a slick 30-second video recording of a feature working in a cozy sandbox environment? That proves absolutely nothing about architectural alignment, long-term maintainability, or how it respects your strict back-end contracts. Do not ship just because the demo worked.
Moving on to Part 2. The release gate architecture. Evidence over claims.
This right here is where we literally have to rewire our engineering brains. We need to understand the fundamental difference between a claim and evidence. In our checklist, checking a box that says, oh yeah, it handles errors well, that is merely a claim. Honestly, it's basically a rumor. Actual evidence is an automated test log. It's an annotated ground truth data set. It's a traceback showing exactly how the system recovers from a crash. If you can't point directly to the artifact, the evidence doesn't exist, period.
Which brings us to the core structure of this checklist. For every single critical control in your AI system, you need two absolutely non-negotiable fields: evidence and a named owner. Now, a named owner means a specific human being who is responsible for stewarding that model's knowledge, reviewing the logs, and holding the line if the evidence isn't there. Because let's be real, shared responsibility in AI deployments usually just means absolutely nobody is waking up to answer that PagerDuty alert at 2 a.m.
All right, Part 3. Testing the refund agent, a worked example.
Let's ground all these abstract concepts by stress testing a really sensitive scenario, an AI agent that is actually empowered to issue real monetary refunds. High stakes, right? Notice how specific the evidence has to be here. Say a customer ordered a t-shirt and a ceramic coffee mug, SKU mug-001. The mug arrives cracked. They ask for a refund. Now, does your agent blindly refund that entire multi-item order, or does it correctly parse the intent, specifically invoke the refund tool for just the $19.99 mug, and output a nice, human-friendly confirmation? Having a structured evaluation format like this lets us automate scoring across thousands of scenarios, rather than just guessing.
And passing this release gate requires strict quantitative thresholds. For a refund agent, the deployment criteria might demand at least a 95% tool recall on refund and cancellation scenarios. You literally need automated gating mechanisms that will actively block promotion to production if any regressions pop up during multi-turn tests. This is how you prove the agent isn't just getting lucky on a few prompts, it's statistically reliable.
Part 4. Planning for AI failure. Edge cases and resilience.
Out in the real world, your users are definitely not going to give you perfectly formatted inputs. It's going to get messy. You have to validate input and output handling for those messy moments. Like, what happens if a user types a malformed order ID with a weird typo? Or what if they send an ambiguous request blending two intents together, like asking to cancel for refund on an item that has already been delivered? The evidence here has to show that your agent gracefully clarifies the situation or escalates it, rather than just firing off some erroneous tool call that bleeds company money.
We also need hard evidence for total system failures, because AI does not live in a vacuum. What exactly is the fallback behavior when your downstream payment provider just times out? How does the agent handle a duplicate request or a totally missing order? You need undeniable proof of safe retries, idempotency, which just means a delayed double-click by the user won't result in a double refund, and a very clear rollback or remediation path for when the whole thing just gets stuck in an unknown state. And listen, for high-consequence actions like really high-value refunds, you need evidence of a strict permission boundary and human escalation. Lots of models can output a certainty score, say from 0 to 1. You can actually set a threshold, like anything below zero point 0.7 confidence automatically escalates to a human reviewer. This proves you have a real safety net in place that perfectly balances automated load with absolutely necessary human oversight.
Which brings us to Part 5, Observability and System Limits. Trust but verify.
Monitoring a probabilistic AI agent is a completely different ballgame than tracking your standard software crashes. Failures in production aren't just incidents to resolve. They are literal test cases. See, when an AI agent misunderstands a prompt but doesn't actually crash your server, traditional monitoring completely misses it. Everything looks fine. So you need semantic and technical observability. Every time the agent breaks in production, that specific trace must be captured, analyzed, and turned into a brand new regression test to make sure it never, ever happens again.
But a quick reality check for the devs out there, please do not log everything. If you try to log every single full prompt and response for a busy AI app, you are going to generate like 10 to 50 gigabytes of data a day. It is completely impractical. The evidence we actually look for here is a targeted strategy. Track the request IDs, timestamps, token counts, and latency across the board, sure. But then only sample about 5% of your non-critical interactions for that deep semantic analysis.
You're also going to need evidence of strict action, cost, and time limits. We need to see metrics showing tool call success and failure rates, and crucially, tool use rate limits. Without these hard limits, an LLM might just get confused and stuck in a loop, endlessly retrying a failed API call and burning through your entire token budget in a matter of minutes. Show me the evidence that your system is going to automatically pause or fall back when that retry frequency spikes. Finally, Part 6, the final release verdict, ship or hold. Okay, we've reviewed the test cases, we've looked at the edge case handling, and we've verified the observability metrics. It is time to face the release gate. This is the moment of truth. You are standing before the team. Sure, the demo looked amazing 2 weeks ago, but now, looking at this rigorous checklist for our refund agent, do we actually ship? There are really only 3 acceptable answers at this gate. Option 1, ship. This means every critical control has a named owner and verifiable automated evidence proving it actually works. Option 2, ship with conditions. This means we pilot the agent to a small subset of users with rapid rollbacks enabled and strict limits on how much money it can refund per day. And option 3, hold. Listen, if a developer checks a box saying handles API timeouts but cannot point to the test log proving it, that is just a claim. It's not evidence. The verdict is hold.
I want to leave you with this final, crucial thought as you go back to evaluate your own AI pipelines. Ship, because you can actually show the evidence. A demo proves feasibility. Production proves the engineering. So the next time your team is cheering at a flawless, magical local demo, ask yourself, are we shipping a system or are we just shipping a rumor? Thanks so much for joining me on this explainer, and I'll see you next time.